I'd like to introduce myself. I'm Professor Gail Whiteford, and I'm the Pro-Vice-Chancellor for Social Inclusion here at Macquarie University, which I tell people is about one of the best jobs to have in Australia. Part of what's in my portfolio is outreach, and that means programs that we have in schools like your own, not only in Sydney, in New South Wales, but also around Australia. And right now, for example, we have some programs running in the Central Desert with Indigenous students. That's outreach. But there's a special group I'd like to acknowledge here today who are one of our new partnering schools, along with Sharon, and that's Auburn Girls High. Can you put your hands up for me and the teachers? A special welcome to you all here today. We're delighted to have you on campus with us at Macquarie University. Some of the other things I do in my portfolio are Indigenous strategy, and I know you got an acknowledgement of country this morning. We have some very exciting partnerships running with a range of Indigenous communities. And today's focus is science. We actually have a project where a group of our scientists are working with Aboriginal elders to understand why bush medicines work. How cool is that? But really importantly, what's in my portfolio that I'm passionate about is equity and diversity. And that's about ensuring that everybody has the opportunity equally to come to Macquarie and participate in a higher education. We want Macquarie to be a vibrant, diverse, and exciting place. And people like you are all part of that picture. So, women and the representation of women in higher education is looking good, but the representation of women in science still has a way to go. Before I go on, there's another subgroup of people I want to acknowledge, is all the teachers. Can you put your hands up? All the teachers who are here, don't be so shy. Come on, wave those hands around. Okay, I'd like to acknowledge your really important roles. For the students, these are the people who lead, who make these opportunities possible, along with our team here at Macquarie. So can we thank the teachers? Now, women in science. I just want to tell you a really quick story. 2 years ago, I was on my way to do some lecturing in Switzerland. Tough job, but somebody had to do it. And I was changing planes in Paris, and I got off my plane in Charles de Gaulle Airport. Who's been to Charles de Gaulle Airport? Oh, okay. A few people have. Very good. It's very big, and there's a new part of Charles de Gaulle. And when I came up the stairway, there was a big sign that said in French, "N'oubliez pas, don't forget, the contribution of women in science." That banner was not maybe quite as big as this room, but pretty close. Imagine that. Every international visitor that arrived in Charles de Gaulle Airport in Paris sees a sign that says, "Don't forget the contribution of women in science." That really inspired me, and today we're in a similar spirit. We're recognising and celebrating some of our absolutely outstanding scientists, women scientists in Macquarie, and you'll hear about them in a minute. But I want you to, n'oubliez pas, don't forget the contribution of women in science. And we're going to hope that it inspires you to think about a career in science. Anyway, on to the stars, our panel for this afternoon. Let me introduce them. First of all, Dr. Leanne Armand from the Department of Biological Sciences. And let me just tell you, Susan squeaked in a little bit late. I don't know if you noticed. Do you know why she was late? She was sitting down spending time with a first-year student, giving them advice about their academic choices. That's the level of commitment that we have in our staff. So she's still catching her breath. We're going to give her a bit of time to do that. Next, we have Susan Munier, who's a graduate engineer, Communications and Control Systems from the Rail Corporation of New South Wales. and you're going to hear about engineering as a career from Susan. Next, we have Associate Professor Orsola De Marco, lecturer in the Department of Physics and Astronomy. Welcome. Dr. Sarah Hemley, who's a research fellow in neuroscience at the Australian School of Advanced Medicine. Next, Dr. Natalie James, and we're particularly pleased to have Natalie here. She's a principal materials scientist from Cochlear. And finally, Dr. Jasminka Jaksic, who's a Technical Development Manager, Measurement Institute, Department of Industry, Innovation, Science and Research. And proudly one of our graduates. We do have stellar graduates who end up going around the world in careers in science, but you're going to hear more about that. Now, the way it's going to work is I'm going to ask panel members some questions. They're going to give you the inside goss, okay? They're going to tell you things that are truthful from the heart, and they're going to speak from their experience, because we believe that's how we all kind of advance, is learning from each other, and it's particularly true for women. So I'm going to start with Sarah, because she's at a particular point in her career, and a very exciting point, I think, Sarah. So how about you tell our guests here this afternoon how you got started, what your interests were, and what you liked most at school, and how that perhaps shaped your career to date. Over to you.
Thanks, Gail. Can everyone hear me? It is working? Okay. Although I was really interested in how things work and science at high school, the subjects that actually were my favourite and I excelled in were English and English-based subjects like modern history and things like that. But when it came to Year 12, I thought I couldn't think of any of the traditional jobs that involved English or majoring in English at university that I was really interested in. As much as I admire high school teachers, I could never imagine myself being an English teacher. I didn't want to be a lawyer, and so I wasn't sure what I actually wanted to pursue. My sister was already at university doing medicinal chemistry, and so I decided to look into science. And when I did so, I found that a Bachelor of Biotechnology, which allowed me to do science, but also had lots of interesting subjects that involved writing essays and thinking of philosophy and bioethics. So I started into that and found it really interesting. It gave you the background of science, and I did lots of subjects like genetics and molecular biology, but I also got to think of the impact of science on the community and answer philosophical questions and look at science fiction films and the impact they have on our everyday life and how they predict the movement of technology or the way that science actually impacts on society. And I found that really interesting. And so by the time it came to third year, I actually loved what I was doing. I decided to do an honours project, which was looking at the effect of the ozone hole on Antarctic moss. And then after finishing honours at Wollongong University, I then worked at a lab at Sydney, working on mutant mice, trying to find out what genes were responsible for these mutations. After that, I decided I just wanted to go travelling, and I just backpacked around Europe and India and South America for about a year. Came back to Australia and needed a job, and I applied for a position as a research assistant in a neurosurgery laboratory looking at spinal cord injury and a condition that occurs in people with spinal cord injury. And once I was working there for about a year, I discovered that I loved neuroscience, and it offers quite a few, I guess, unique advantages. You get to travel the world at conferences. There's a definite clinical basis for all of the research that you're doing. I work with a neurosurgeon, so I get to see the patients that are actually affected by the condition we're looking at, watch the surgery and see the scans and find out the progress of these patients and why the research I'm working on is so important. So then I decided I wanted to pursue this as a career, and I started a PhD in the same lab which I completed last year, and I actually graduate next month. And so at the end of last year, I started working at Macquarie University as a research fellow. And working here at the Australian School of Advanced Medicine, it is a very unique place. It's directly attached to the hospital. So you do get to, there is a lot of collaboration between the surgeons and the research itself, as well as the rest of the university. So yeah, it's a great place to work.
Okay, I think you talked about what influenced you at school, but you also talked about opportunities that came up later on.
Yeah.
Do you want to expand on that? Because I know you feel very pressured when you're at school about subject selection, right? Like you get really anxious about it, but maybe there's a way in which, you know, you can, the pathway later on, other opportunities come up that mean your subject selection is important, but not as crucial maybe as we think.
Yeah. Well, I guess if you do go into science in general, I mean, if you look at the different places I've worked, I started off doing environmental work in my honours degree, and then I went to genetics and then medical research. So I think a career in science doesn't mean that you just have to stay in one particular discipline, at least in research and within the kind of biological sciences. There's a range of things that you can do within that. And at university as well, if you do have a diverse range of interests like I did, you don't have to just stick with the science subjects. And at most universities these days, they give you a wide range of things that you can look at. But yeah, I think the unique thing about science is that you're not stuck doing one thing. If you didn't find science itself or working in a lab interesting, there's lots of areas that you can go into in terms of policy and things like that, where you wouldn't do research itself, but look at the policy behind the research and apply it and work for the government that way. So I think no matter what you choose at university, there's such a wide range of career paths that you can go into that you're not just stuck, or the choices you make at university don't put you into one position and you have to follow that for the length of your career.
Well, that's good news. Do you want to finally talk to us about what's exciting about working in a laboratory? Because people have a lot of preconceptions about that. What do you get excited about when you're working in the lab?
Well, I think one of the things that I love, it is so varied. I think most jobs involve sitting at a desk each day and wearing a suit. And I'm actually very dressed up today. I usually wear jeans and a singlet. And the only thing I really have to wear, I'm not allowed to wear thongs, so I have lab shoes under my desk, which have closed-in toes because that's the only prerequisite to working in a lab. But everything's varied. I can spend a day looking down a microscope. I do microsurgery on rats, so that will be one day. But then I also end up doing a lot of the writing that I love. So I write papers for journal articles. I spend a lot of time reading papers and peer-reviewed journals to find out what other people are doing in my area. Other days I could spend doing dissections or pipetting out chemicals and things like that. So it's such a varied position that some of it's behind a desk and other parts are in a lab doing various things, as well as working as a team and trying to troubleshoot, because science is quite difficult. You're not just given a protocol and you have to just go and follow those steps. You have to think about everything you're doing. So it's always changing, you're always learning, and for that reason it's really exciting.
You're passionate about it?
Yeah, especially neuroscience and this particular spinal cord injury, because I guess working at the Australian School of Advanced Medicine, you get to see the impact that has. You see the patients with the condition, so you, I guess, directly see the impact of your research, and you can clearly see the end goal, which is to develop better treatments for the disease.
Thank you. Thank you, Sarah. You'll have an opportunity to ask further questions of Sarah later and follow up on any particular interests that you may have. Next, we're going to move on to Associate Professor Ursula De Marco, and very different field of science that you're in. Now, how for you does it feel to be a woman in a more male-dominated area like physics?
It's great. There's great things and there are some challenges, as you can imagine. The great thing is that when you're a scientist, you'll always have your own brain to rely on and your own little subfield that you like to do investigations in. So you have to rely on your own, let's say, brilliance, just because I'm positive. However, you always have to work an angle. Why am I right now the best person to do this? And aside from your brilliance, it's also sometimes because you have little things that other people don't have. And when you're one of few women in a world of mostly men, what do women have that men don't?
Okay, so, maybe we won't answer that question fully. But
there's one thing that is really good, is that I think we're a little bit more sociable. We understand others maybe a little bit better. And so I have great collaborations. I build really large collaborators where I can bring people together to all concentrate on the same problem from different perspectives. And by doing that, we really solve questions. We give answers. Now, some of my male colleagues might be more loners. They work a little bit more alone, or maybe in smaller collaborations. And that's fine also, and that has its own edge. However, what I do, I just have large groups. And it's really worked out great for me. So in that sense, I can say that's a good thing of being one of the few women, because I work my edge in that way. However, of course, there's also some downsides. As you can imagine, I mean, if we lived 50 to 100 years ago, you might imagine your boss telling you, well, you shouldn't really be in this field. You should be in the kitchen. But that's not true anymore. Fortunately, we have progressed. So you don't see that very often. Maybe some of the older generations might still have some preconceived ideas, but not so much. However, there are what I call unconscious biases. So sometimes a good example is there's a room of people discussing a problem. You're the only woman. You raise your hands, you say your opinion, and then nobody reacts, and then the guy next to you says the same thing, and everybody goes, oh, yeah, that's a really good idea. And you think, I just said that. So this happens quite a bit, and if you take a lot of physicists and astronomer women and ask, has this happened to you? I can guarantee like 90% will say yes. So still there is a lot of fighting to be done in that area, but how do we fight? The best way is to let people like you guys know that you can have a career in science if you like it, you're going to be great at it, and you should never worry about there's too many men, too many women. It doesn't matter. Just do what you have passion for, and it'll be fine. And what we'll achieve if you do that, we'll get equal numbers, right? Once the population's 50-50, these biases just go away over a little bit of time. So there too, there's really great hope. And I can say that while in physics there's still a lot of men, more men than women, in astronomy, which is my field, there's in the student ranks, so the young people, PhD level and a little bit after, it's 50-50 already. And that has had amazing repercussions in the field as a whole.
Thank you for that. I think you've pointed out some really important differences but strengths for women in science. Do you want to tell us about some of the highlights of your career, some of the moments when you went, wow, look at me?
I guess coming here has been one of them. So after my PhD, I did, like most of us, sort of after you do a PhD, if you want to go into research, you might do some, they're called postdoctoral research assistantships. You basically go for 2 or 3 years and do some research. And eventually you're trying to get a job either in a university, depending on the field. It could be in a lab or in a government institute. Oh, but that sounds like a prison. I mean, in a government institution. Okay, better. And so, however, for me, I was for many years doing research only and basically writing grants to support my own salary, which was great. I was really free, but it's a little bit kind of high pressure because if you don't get that grant, you might not have enough to eat. And so at some point, with the bulk of research that I had accumulated by about 3 years ago, I applied for the job I have now, Macquarie, and I just went for it with absolutely every tool I had. And I got the job, and I just, you feel really like, I always reach the stars, that's my job, but it was even above that. And so it was really, that was the great highlight. And then starting here and having the students and getting grant money, and it's just been wonderful 3 years.
Do you want to tell us about your particular area in astronomy?
You all guys know, right? We've got planets, You've got stars, bigger. You've got galaxies, even bigger. Clusters of galaxies, even bigger, and then the whole universe, the biggest. So you can think of astronomers as being attached to this kind of hierarchical fields. So I do stars, bigger than planets, smaller than galaxies. And in particular, stars like the sun, right? And in particular, I am interested in the interaction between a star and its planetary systems. You might know that, until 1995, so that's 15 years ago or so, yes, we only knew of our own solar system. We didn't know of any other planets. But of course, people since the 1600s were thinking about there should be other planets, right? There's so many stars. And indeed, since 95, we've now discovered about 400 extrasolar planets, planets outside our sun. So we really started wondering, how do they come about? How do they form? How many do a normal solar system has? We have about 8, but could there be 1? Could there be 20? And even more recent has been the question of whether planets interfere with their stars. We know the sun will grow when it kind of becomes a little old in 5 billion years or so, and it'll completely wipe Mercury, Venus, Earth, not so good, and even the outer solar system planets will just move further out. So the question is, well, planets can get wiped out, but can they have an effect on their mother star? Could the fact the sun grows and it eats all its planets blow up the sun or destroy the sun or change the sun? So since this question has arisen in the last maybe 5 or 6 years, I've been really active in trying to give it an answer, to really understand, we know stars evolve, they're young, middle-aged, and eventually they die, but is that because they have children? I guess that's an analogy. Is that because they have planets that help with that process? So I don't just use my mind, and I don't just use observations, just big telescopes observations. I also use the computer to extend my mind and to try to help me figure out how these interactions work and what happens when they do.
Wow, okay. I'm sure that people will have a lot of questions for you about that, but do you get a sense of the excitement that comes from doing this kind of research? And I would add that Ursula is known internationally for her research. So I'm going to move us on now to Leanne, and I'm going to come over here. Leanne, do you want to tell us about how your career has given you opportunities internationally and your international research connections, picking up on that theme?
Okay, so welcome everybody first. It's great to see, first of all, so many happy, smiling faces, because we're on the other side here and it's really inspiring for us to see so many people alive here. So obviously you're interested in science and you're interested in what we've got to say, but I actually have 3 questions or 4 questions to ask first. Before we talk about international travel, because it's related to this. First of all, who knows what subject they're really, really good at school? Just put your hand up. If you've got a subject that you absolutely love, you know you're good at. Okay? In my case, I can say, when I was at high school, biology. That's it. Okay? I was only good at one subject. Okay, the rest I just sort of, okay, I'll do them, and I can do them if I want to try really hard, but the one that I loved was biology, so I can say that. Who has absolutely no idea what they want to do when they get out of school? That's what happened to me. No idea. Just knew that I liked biology. Okay. All right. So I signed up to uni. I signed up to all of them, saying, okay, well, I'll go into the Bachelor of Science and do biology because that's what I'm good at. Okay. Who actually thinks that they might travel with their future job? Who'd like to travel, I guess, is the thing, right? Okay, yeah, me. I thought, yeah, I'd love to travel. Now, I can tell you that my travels have now taken me to Antarctica many times. And did I actually think that I would ever go to Antarctica or ever work in the Southern Ocean? Absolutely not. Okay? So I just want you to have this picture that when you're at high school, the doors are only just beginning to open. You do not have to select at all where you're going and what you want to do. But one thing to really know deep inside of you is what you're good at. Okay, try and at least ask yourself, at the end of the year or sometime during the year, what am I really good at? What am I actually really inspired by? And I think most of you could probably at least pick one subject, and that's really important to hang on to that and say, okay, this is what I'm good at, this is where I should probably look at something in the future, and keep that option open when you start selecting where you want to go and what you want to do in the future. Okay, last question. I imagine most of you have Facebook accounts of some description. How many of you have a friend, and I don't know how close that friend may be, but how many of you have a friend who's international? Okay, pretty much all of you. So what I'm saying to you is your future is very international already. The fact is you already have international connections, and in your future studies and your future jobs, that internationality is just going to go ballistic, okay? Anything that you do will be on an international level pretty much in the future. So you're already halfway there to being internationally connected, the fact that you're already got those connections, and that might be family connections to some degree, but it's also a fact is that the science that, or in my case science, or the job that you might be looking at will probably be very international by the time you get to university, and even when you go out of university into the world. So international travel, I can tell you that I pretty much didn't travel anywhere until my PhD. I think I had been to America on a youth exchange to America, so that even though that was culturally different, wasn't terribly culturally different, but since then, my PhD, I threw myself in the deep end. I was given an opportunity to continue studying vertebrate paleontology, so digging up Australian fossils, or the alternative was to go to France, knew no French whatsoever, never studied a language properly, because, you know, I wasn't really interested, at high school at least, and then threw myself in the deep end, learnt French. I'm now married to a Frenchman, I might add, so, you know, it was all coincidence. And have since continued that collaboration with the French university that I went to in my PhD, and it's almost 15 years now that I've been working with this laboratory, but that laboratory opened so many more doors to me, so I've worked with Germans, the US. I have continued to work in a lot of oceanographic sciences, so I'm now not a vertebrate paleontologist anymore. I am an ocean scientist. Essentially, I work on micropaleontology, so fossils from the seafloor of the oceans, and also the organisms that we essentially are at the base of the food chain called diatoms. I don't know if anyone remembers that from Year 10 biology. No. Okay, teachers, get on to them. First test. What is a diatom? No. So essentially, I've been out and about on a lot of different organisations and universities and institutes around the world. My science is purely international. Now, when I bring that back home, I come back to Macquarie University. I am a little bit on my lonesome sometimes. I still do a lot of Antarctic work, and I teach Introduction to Marine Science, so I have a lot of my colleagues around, but my science still remains very much international, Southern Ocean and Antarctic work. And my colleagues are all colleagues that I converse with on the internet, by Skype a lot as well, and through meetings and workshops and the like. Now, I'm at a point in my career now where I'm actually organising oceanographic missions, and so I'm bringing in international people, and I'm also, last year, ran a workshop on diatom taxonomy, so identifying diatoms, and again, bringing in lots of different people, students from other countries. So I've got a cultural exchange going on constantly in my laboratory, and I have students, one's from Germany now, I've got another one coming from the US, and I have a couple of people from Indonesia who are interested in coming over. So my science is very much an international one.
Well, you're making that sound very exciting and very glamorous. And remember, look up diatoms. That's your homework. But what are the challenges in what you do? What are the bits where you have to kind of grit your teeth and really commit and dig deep?
Okay, so I guess one of the hardest things for me is I'm also a mum with a teenage son and a primary school age son as well, so 11 and 13. And so being a mum and also going to sea has its difficulties. So, you know, there's a lot of family support that kicks in. But I also have two sons that are very resilient and know that I'm going to be at sea for up to, 2 months of a year. But at the same time, a difficulty is actually, Oh, what else is difficult? Getting money, I guess, is one of the biggest things that we all have as challenges. Antarctic science is extremely expensive. Just to get a ship on the water is $80,000 a day, which has to come from somewhere. So, but there are, I mean, don't think that I just go out there going, please, with a sign, please, starving woman needs $80,000 a day. No, don't have that sign out yet. No, there are granting opportunities out there, and so I'm at a level now where I'm actually leading those granting requests. So recently I put in for a 45-day mission from Tasmania down to Antarctica, and that's for 2013/14. So we plan well in advance, we have an idea of the people that we want on board with us, and we put in a request for that ship time to be funded. And then we build up the projects based on the people that are involved. So there is a lot of difficulties probably in just organisation. You have to be an organiser at some stage, and again that comes into being a mum as well, and fitting everybody's needs in, and fitting your own needs in is very important, and sometimes you end up last on the list, but at the same time I'm very, very passionate about the oceanographic science I do, and I also feel very responsible for making sure that we continue that international connection in Australia.
Leanne. Now, Susan, we're going to pick up another different field altogether here. We're going to hear about engineering. I guess I went to uni with a friend who was doing mechanical engineering, and she said that in order to get her voice heard in tutorials, she had to stand on the desk and wave her arms around. Do you want to tell us about engineering and what it's like, again, its suitability in terms of being a woman going into engineering, and tell us about the particular field of engineering that you're in?
Okay, that's a very interesting question. Historically, engineering has been a male-dominated profession. Historically, yes. I won't lie to you, that's true. However, today the scenario is changing. So more and more women are entering into the engineering profession, and more women are staying in the engineering profession. So you're no longer the only female in your team. So that's a great encouragement. But if you look at other professions, for example, law or medicine or politics, finance, 20 or 30 years ago, it was also male-dominated, but it has changed over the years, and engineering is getting there. As part of that process of the change, I feel that I have gotten immense support and encouragement in the engineering field and industry as a female engineer. So my advice to you is, if you do have a passion for problem solving, which is what engineering is, do not let that male dominance hold against you. If you are the only one in your class that has to speak up, the benefits of that is all those guys will come down to help you. Another quality I feel that women have in engineering to contribute to engineering is that women have a lot of compassion and empathy that might be less in the male. So when you're in a room full of engineers, you have a different perspective to offer. You have a unique approach to problem solving that your male counterpart might not have thought of. So you have a sense of accomplishment that you have made a great contribution to the problem that you're solving. Engineering is a very diverse field. So there are different disciplines. There's mechatronic engineering, there's biomedical engineering, there's electrical engineering, there's aeronautic engineering, there's telecommunications engineering. Whichever field of science you'd like to go into, if you like solving problems, engineering is the field you want to go into. Another aspect of engineering is that most people don't realize is that you don't have to be an engineer. You can go into different other related jobs, such as policing, like Sarah has said to you before. You can go into project management. You can go into analysis and modeling as well. So you're not restricted to hardcore design. Yeah.
Okay, so we hear a lot in the media that there's a world shortage of engineers. Do you know why is that? And what should we be doing to address that?
That is true. There's a shortage of engineering, mainly because it's a very challenging profession. there's a lot of science and maths involved, and not a lot of people want to take on that passion. However, the other side of that is it's a very well-paying job, and there's a lot of job satisfaction to it as well. So engineers have contributed to examples such as hearing implants. So you can contribute to changing the life of a person. They have contributed to communication systems. So, for example, in a remote location, you can provide underprivileged community with electricity or communication systems such as the internet, which might be life-changing for a little child. You can contribute to providing water supply as a civil engineer to remote communities. How we can change that scenario is to take on that challenge and look at a problem and say, there's a problem there, and I'm going to use my capacity to solve that problem. So do not let a challenge stop you, rather take it as an opportunity to contribute back to society.
So you make it sound like engineers help make the world go around and work, really? Is that right?
To some extent, there's a contribution to every single field by an engineer, to some extent.
Thank you. And I think you mentioned the contribution through, for example, the engineering contribution in hearing implants, which is a really good segue into Natalie's presence here and what Natalie might talk about representing Cochlear, who we're co-located on our campus. Very excited about that relationship. Do you want to tell us about what the value of a science degree is generally, and also talk about your career?
Certainly. Good afternoon, everyone. Studying science really equipped me with a platform to understand biological interactions and also subsequently the materials that were used for the implant. And when I set out, I really wanted to work in a position where there were good, strong expectations that I would be able to contribute in a way that helped the community, and I also have quite a passion for improving existing technologies. And so my science background gave me great opportunity to be able to do that. So firstly, I started at a company where I worked on a ventricular assist device, which is basically a heart pump. It's like an artificial heart. And what I did as one of the roles there was to work on looking at minimising the damage to the blood cells. And so we would do experiments where we could provide feedback to the mechanical design engineers so that they could improve and optimise the design of the pump. And another aspect of the work that I did there was work on the carbon coating that was used to line all of the blood contacting surfaces of the device. So in that role, we had to work with material scientists and also with physicists from local universities, and we managed to develop then a coating that is the best type of coating for this type of pump in the world. In the device itself has been really technically innovative and successful. And since working on the heart pump, then I've joined Cochlear. And in the work that I do at Cochlear, I work on new technologies at the frontier of technologies that could be applied to the device. So I'm working on nanotechnology applications, I'm working on antimicrobials, optical fibres, and also new polymers that could be valuable for the implants. And one of the great opportunities that I have is to look at ideas and concepts and see them flow through into performing and improving the performance of these implanted devices. And another great thing about this is the great collaborations that has been mentioned by the other people on the panel here. And one other thing also is that I did want to go work overseas when I was finishing off my PhD, and through a postdoctoral position I was able to do that. And so having a science degree was really a really good platform to be able to do that.
So do you want to summarise then for everyone sitting here listening to you, what would be some of the key reasons to pursue that science degree and that science pathway? You've spoken, for example, about making a difference to people's lives, and it sounds like you have through your work, but what would be the key reasons that you do science for all these people sitting here? What's in it for them?
I think probably the biggest thing is that you can make new discoveries. You can contribute to the world. You can contribute in all sorts of ways in development of understanding, in understanding the way the world, biology, materials, or astronomy, all sorts of areas work, but you can also then have an opportunity to use these discoveries to contribute and develop new technologies and new understanding.
Make a difference in a big way. Okay. In terms of making a difference, there are lots of ways that we do that. We do that through our work, and sometimes work and family life come together in interesting ways. We've heard a bit about that from Leanne. But Jasminka, do you want to talk to us about how do you get that balance, if there is such a thing? I'm not entirely convinced myself, but how does it work? How do you pull it all together and still, you know, meet your career goals and do the exciting work that you need to do in your area?
Right. Well, sort of put it in simple terms, yes, you can have it all. But to some extent, certainly. I'll give you a little bit of background what I firstly did, and then I'll just connect it to how work and how science relates to family, and how you can make that balance. I started when I was about 5 or 6 years of age. We had this issue with ants in our front yard, and I pretended to be a big scientist, and I was trying to make this new drug that's gonna kill them because I really hated them. Anyway, so I went down to my mum's laundry and started mixing different chemicals, and and started putting this much of this one and that much of that one, and didn't work. Okay, well, let's try different proportions, and it was quite actually intriguing. And I was educated in a different system. It was a European system. I come from Europe, by the way. But it was just that we had a different type of educational system where we had to, when you turn 14, you essentially had to choose your career path. So there was no sort of high school as per se. We had to choose a certain degree. At the time, I'd chosen medicine, and I did that in 4 years, and I graduated as a nurse. And I worked as a nurse for a little while. However, human body in general was very intriguing, and I always wanted to know how human body works, and I wanted to go to nitty-gritty sort of bits and pieces of human body and see cells and everything. So I decided to do science. And I did science here at Macquarie Uni, and I did both biology and chemistry. However, I found chemistry to be much harder, so that's why I did it. And I also find it to be more interesting because I kind of like to be organic chemist, and I wanted to mix bits and pieces. And again, coming back to when I was 5 or 6 years of age, I was mixing components and trying to get the appropriate drug. So during my honours degree, I did medicinal chemistry, so I was trying to find the drugs for couple of diseases, including AIDS and malaria and etc. But during my PhD, I concentrated primarily on one particular human body part, and it was eye. I was trying to find the cure for cataract. And that was quite interesting because Lavanya, as you've heard from the other panel members, throughout your career, you can actually you can collaborate, establish collaborations, you can travel, and that's what really PhD and that particular project allowed me to do, is to do 10 different conferences, collaborate with different people, either nationally or internationally, etc. So upon completing PhD, I postdoced, again for a safe site institute here in Sydney. And again, I continued my work and worked on cataract further. Once I sort of, throughout that position, I realised you don't necessarily have to be, if you have a science degree, you don't necessarily have to wear a white coat. So I wanted to see what else can I do out there to contribute further to human existence and generally to our planet. So I started to work for a commercial company where I was doing applications in terms of instrumentation, applications designed for instrumentation that would be able, which we'll be able to use for different testings. Either it could be a human sample, so blood, urine, etc., or it could be environmental samples. So I was the one key person that was involved with the training of customers. And that position allowed me to travel nationally and internationally. So I did that for 3.5 years, and in 3.5 years I pretty much traveled around the world. Being that that company that I worked for was international, it allowed me to go to States pretty much once a year, to Asia every 3 months. So it was just absolutely great. Through that, you clearly learn a lot. You establish collaborations, you establish friends, and that's really, really important. Again, that community was primarily male-dominated community that I worked for, so I really had to work harder and prove myself much harder. And clearly, it was slightly different to what I'm used to, but however, you know, I really have enjoyed it, and I did succeed quite a lot, and I'm quite proud of that achievement. Recently, I've moved to a government institution, and now I work for National Measurement Institute. And what I do there, my role is Technical Development Manager, where, again, I don't necessarily work in the research, so I don't necessarily have to wear a lab coat, but I'm involved with the research and I'm involved with the development that we generally do. And my laboratory is an environmental laboratory, so we deal with environmental issues. So you probably have heard of coal seam gas and explorations that are happening around the states, not just New South Wales, but primarily in Queensland at this point of time. Well, my group is involved with that. So we work with the politicians and policy creators in Canberra, and we try to look at the best way to tackle that issue, for example. So once again, if you are a scientist, I started as an organic chemist or medicinal chemist, and I really have moved sort of across that and sort of gone into a really environmental field at the moment. So as previously stated by the members of the panel, you don't necessarily have to start with one area and then just do that for the rest of your career. You can essentially jump from one area to the other, because every area can find you very useful. Your experience and expertise in that particular area may be useful in another area. And how do I put this all together and then have a family? And mind you, I have a daughter that's 21 months old. So it's really easy kind of thing. You just have to make sure that family comes first. And that's my motto. Family is always the first on your list. I do love my job, there is no doubt about it, but who do I love most? I really do like my family most. At the end of the day, if you have established yourself in the field and you are an attractive candidate to your employer, any job is just a job, really. If you can contribute there, if you can give your 100%, that's great, because you do really like your field and you like your job. But you kind of have to think about the family as well, and it took me a little while really to get to adhere to have a family. I think it took my husband about 3 years to convince me to have kids. But you know, I'm really glad that I did it, and I did it when I was 30 years of age, and there is absolutely not a single regret with that, that I left it kind of a bit later. But in a sense, I think it's a perfect time, because then you really have established yourself, you established your career, you have a great job that you absolutely love, and you're going to be able to provide your family and your kids a great support, and the kids are going to be proud of you if you can contribute it through your career to a community and to generally to your human beings.
That's a very good note for us to begin to wind up on. And I think one key message that I heard from you, Jasminka, is that there's not a wrong pathway. Everything that you learn and do contributes ultimately to what you end up doing. So that it's not a wrong pathway. You don't make wrong choices. You don't need to get too upset about choosing a particular subject in year 11 or 12, because eventually you'll find what you want to do.
Exactly, very true, very true.
Okay, we're going to have, this is a little off script here, but I think it's important. There's time for about 3 questions from the floor. You are going to get time downstairs in the next session to ask, in a more intimate gathering, questions of staff. But here's your chance, having heard this amazing group of women scientists here, to ask a question that you might be burning to hear from the panellists in front of you. We have a roving mic. Who is game? We've got someone over here. Do we? No. Remember, you've heard about being bold and having your voice. This is your chance. Nobody's game?
Any takers?
Oh, there's one here. Great. Oh, I love people that jump in first. That's great. Do you want to tell us who your question is directed to, or if it's a general one?
Well, it's just a general question.
Okay.
I was just wondering, like, if you have an interest in something, but then you don't really have, like, a support from your parents, what would you do to overcome that? Like, how would you pursue?
That's a really good question. Really good question. Panellists, who would like to respond to that? Now they've gone shy on me. Okay, all right.
Am I on? Yes. Yeah. Okay. I think that is definitely a difficult question when you've got parents who have ideas about maybe where they would like you to be and what they would like you to do versus what you may actually be interested in. So I didn't come necessarily from a household like that, but I certainly came from a household where science wasn't actually understood at all. But my parents at least supported me. They knew I was very good at biology, and I thank my mum because she went out and bought me a biology textbook because I kept rabbiting on about biology. So she went out and bought me just a general university textbook, which was, a godsend at the time because that spurred me on further. I think there's 2 things I'd suggest to you. Make sure you talk to your student counsellor at school and make sure that they're aware so that they can actually provide you with some support. That's really important to let teachers know as well, if that's the teacher that you're interested in building up in that area. It's important to let those people know because they can give you support in that area, and also, if you really need to develop a way of balancing what your parents want and what you would like, it's actually good to get everyone involved and talk about it, because that way you might be able to find a compromise that makes everybody happy. So that is one thing I would suggest. And the other thing I can suggest is just hang on to that dream. And if you've got to just bite the bullet because your parents say, I'm sorry, you're going to be doing this, and I can tell you that when you get to university, you can sign up to whatever your parents would like you to sign up to, but in your second year or even in your second semester, you are actually in control of your degree, and you can actually start making changes into what you would like to study. So just keep on to your dream, and work hard across all things, but if you really need support now, please talk to your teacher that you love doing the subject with, and maybe a student counsellor that you've got on probably at your school, and just try and work out a compromise so that everybody's on the same page. That's my best advice for you.
I think, Susan, did you want to add something else there? No?
Am I on? Yeah.
Yeah.
I was just laughing at that point where Leanne has said about university and you have control of your career. You might not know how university works at the moment, but once you've completed your first year of your degree, you are at liberty to discuss it with your career, your advisor from your department, and switch to another degree. So it's not the end of the world.
So you are ultimately in charge of your destiny.
You
is
are.
what you're saying. Thank you.
Definitely, yeah. Hang on to your dreams.
Hang on to your dreams. Okay, we have another question here. I think it's probably our last question. Or
This is to any of you and all of you. Did you have any doubt entering the science career path? I don't know.
like, were they unsure about it to start?
Yeah.
Is that your question? Yep.
Oh,
Natalie.
certainly. I started, as I said, I studied science. And once I'd done the first year of science, it was all very general subjects. And I thought, what am I doing here? I'd taken a year off as a gap year to try and work out where I was going and what I was doing. And then I came back and started studying. I guess one of the things about that was that because I took the gap year, none of the other students who'd been in my school were in science. They were all a year ahead, and they weren't actually. I don't think many of them did science. Some of them did engineering. So I got to the end of the year and I decided I wanted to be an architect. But I had a little bit of a problem about that crisis because it came a little bit late for the enrolment for the next year. And so I did enroll in second year science, and I enrolled in biochemistry and other subjects that I really loved. In fact, it was getting to the second year where I was able to get less generic and more focus and more what was real to me in terms of the study that I was doing, that I found it just fantastic from that point on. So that's my story about that.
So, Natalie, again, there's no wrong pathway, there's no wrong choice, ultimately. You get there if you pursue your passion and what you're interested in. Then any other panellists want to, yeah?
I might just add to that,
Sarah.
because I think one of the scariest things about science is that it's not one of those professions that you see all the time and you know exactly what it involves. I think it's not until you actually get to third year or maybe actually to your honours year where you realise what it's like to work in a lab. Just from doing practicals in high school or university, you don't really get a feeling for it. It's completely different to actually have your own research project and have control of that. So I think just because it's unknown, I think everyone has doubts and it is a little bit scary because of that. So I guess if you're interested, you just have to pursue it. And these days especially, I know at Macquarie University there's lots of summer internships. So once you've started university, you can get a scholarship to work over the summer in a lab, and I think that gives you a real idea of what it's like to work in a research atmosphere here. And I think if you do have doubts about it, I think that's a great way to do it, and you can then always change. I think one of my closest friends, I did science with her, but she started off doing a computing course, changed to science, and then after finishing honours, then went back to do graduate law. So I think these days especially there's so many graduate programs, so even if you do a degree in science, that opens you up to so many other things as well.
And that's such good advice. I think we have a question, one last question up the back. Someone here?
Yeah. Do you get to choose the sorts of projects that you work on and like the sorts of experiments, or does the university choose for you?
Okay.
I'll begin by answering that. In my honors year of university, I was given the list of projects that were being offered, and I didn't like any of them. And so therefore I went and told my supervisor that I want to do something entirely different. I had no background of the subject that I wanted to look into. It was optical fiber and radio over fiber systems. I was entirely supported by my supervisor. They said, if that's what you want to do, you have all our backing, you have all our support to go and do it. I had no background whatsoever of the subject. I went and researched it. It was something I was passionate about, and it was the project I ended up doing.
Okay, Ursula?
I think I'd like to add that definitely it's all about the researcher. It's all about the student. It's all about you guys. It's what comes out of you. So I know that in school, the tendency is to see the books as the Bible, and then everything the book says right, and you make mistakes if you don't learn correctly. However, I already, with my first-year undergraduates, and more so with the third-year undergraduates, I'm starting to teach them that I am not the teacher, okay? So it's really about you. So the books, the papers, my voice, whatever you find on the internet, it's all an inspiration, and then it's about you and how you work through those concepts. And as you grow older and older and more set in the path that you have chosen, it's really about that new thing that comes out of you. And as a university lecturer, it's really the investment of the university is in the person and in their brain and in their choices. It's really nobody's telling you what to do anymore, up to a point. Of course, I still have to go to lecture and do my committees, but really about the research is about your choices.
And that's what we want. We want autonomous, critically thinking students, and we think you're here because you all have that potential. Now, I'm going to begin to wrap us up, and I'm just going to suggest that if you think about a career in science, you might do it because at the end of it, you'll have a career where you can make money and maybe buy a nice car. You might do it because, not maybe an amazing car, but a pretty good car. You might do it because you get to travel to the places that you've heard about and have an international connection. But do you know what? We've heard from our panel here today. You might really do it because you can make a difference to the world. And that's what I've heard from our panelists today. Can you join with me in thanking this amazing group of scientists?